Hi. All right, so now that you know a little bit about what a hydrocarbon is and how it's like the simplest kind of organic molecule, let's look at what happens when they become a little more complicated. You can take that or hydrocarbon chain as a backbone and you can add all sorts of things to it. Sometimes those things are called functional groups, sometimes they're called substituent groups, but it means the same thing. And we're going to look at some of the common functional groups, the things that you attach to those backbones, and how you change them a little bit and how they make new molecules. And then you can take, there's dozens of course molecules you can tack on there and atoms you can tack on there to make all sorts of different kinds of organic molecules. When you make them, just like acids or bases, each of those molecules has a new property. So for example, things that are alcohols in organic chemistry all feature this OH and they all have certain properties, okay? Ethers have an O in the middle and they all have different properties, just like we learned when we were doing the acid and base unit, like for example, bases have OHs and acids have Hs, and each of those groups has different properties. It's the same for organic functional groups, and there are, of course, hundreds and hundreds of different functional groups you can have. This chart breaks down in this way. You got the class of the compound, which is the name, which you also see on this side as well. We'll come back to that. So that's the name of the class of the compound, and then what the functional groups are, the things that you attach to them are in the first column or second column. And then the formula, the general formula, you'll see them here, you see a lot of R's. The R's just means it could be any number of carbons. Like this could be, for example, one carbon attached to an X or a fluorine, or it could be 3 carbons or 4 carbons or whatever it happens to be. They could all be differently. So the R just stands for whatever. It's a dummy for any number of carbons. Maybe you're noticing R prime as well. That means that the two numbers would be different. So maybe on this side, you would see 3 carbons. On this side, you would see 4 carbons. But as long as they have the O in between, that's considered an ether, okay? And then, and each has an example sort of written in this like combo condensed formula with some structural formula thrown in there. So again, not uncommon to see those kinds of things. There's a lot of ways you can write and represent organic molecules. So one that we're not going to necessarily learn, but it's a kind of, you can see condensed formula there, but also has some pieces where you're drawing some structural lines as well, just to kind of give you a better idea of how the molecule looks. The ones that we tend to care about, although there's some other ones listed on here, the ones that we usually go with for this class are going to be halides, alcohols, ethers, aldehydes, ketones, and acids and esters. Those 4. We tend to avoid the amines and amides, but we might circle back to those at a later time. But for right now, those are the 7 kinds of classes of naming that I would expect you're able to do. On this left side, just kind of the identifying the groups. And then on the right side here are the naming rules. How do you use those and what do you do? So when you're going to name something that you've identified as a halide, here are the rules to tell you, like, this is how you do it. This is what you do when you name a halide. And we're going to show some examples of each of those as well. And we're going to kind of look at the most simple cases and go from there. So let's take a look, and we'll just go straight down the line. Let's look at something that is a halide. I will just draw them belowish right here. And I'll try to make them different from the ones that I have that are examples that are examples in this column as well. So we'll start with this one. This is going to be a halide. You can identify it as a halide because it has a fluorine on that second carbon. And I'm going to fill in my groups. I kind of mix and match with some of these. I'll do some structural formulas. I'll do some condensed formulas, or sorry, line drawings as well. So there's my halide. Instead of a hydrogen there, it's got a fluorine. You are going to, when you name it, if I want to name this thing, you can identify it as a halide here. So like this is a halide. Oh, it's got this fluorine in it, okay? And this is an example of how to name one of them, but if you want like how to name all of them, this is the best tool to use for naming. So if I want to name it, I'm going to keep the A and E ending. So there's 4 carbons. 1, 2, 3, 4. So that would be, we call that butane, right, for 4 carbons. We're going to keep that. We're going to keep the A and E ending, and we're going to add a prefix and indicate where. So we got to say that this is a fluorine, so the prefix is fluoro, and then I got to say what what carbon it's on. You can see it's on the second carbon from the left. So when I name this, all those pieces come together, and I call this 2-fluoro, F-L-U-O-R-O, and then butane. Okay, so that's an example of how to identify it. Well, I can identify it because it has an F in it, and then how to name it. I use this naming rules to name it. So we call that 2-fluorobutane. Sorry. Next, you've got alcohols. Alcohols have the same idea. They have an OH on there somewhere. So let's see, 1, 2, 3, 4, 5. We'll call it. I'm going to put an OH right here, we'll say. Now, OH is when you have these substituent groups, you just like draw an OH. Since there's for a line drawing, since there's an OH attached to the end of that line, there is no carbon there. This is the same exact thing as saying 1, 2, 3, 4, 5, and then at the end, there's an OH. Geez, it's like the worst. Okay, there you go. I know these all be hydrogens, but I wanted to show you the line drawing, so I'm not going to write all the hydrogens in there, but that's the same. Those are the two same things, okay? And at the end of this line where I'm pointing right there, there is no carbon, just the OH. So it's like this is the bond between here. This is the bond between the last carbon and the O. Okay, so that's our drawing for it, and let's see if we can name it. So when you name them, if we're going to use the rules right here, alcohols, right here, you drop the E from the A ending and add the suffix. The suffix is right here below. The suffixes are below. So alcohols get an OL ending. So instead of calling this, 5 carbon, instead of calling this pentane, we drop the E ending, so get rid of that E, and then add the OL ending. Again, the OL is right there, that ending. So pentanol, and then you got to say where it is also, okay? That's what it says right here. Right here it says, for alcohols, you're going to drop the A and E ending, and that N indicate where is the important part, indicate where. So this is on the first carbon from the right, so we call it 1-pentanol. The 1 is telling you where the OH group is, and the pent is telling you 5 carbons, and OL is telling you that, oh yeah, it's an alcohol, all right? Ethers have their own set of rules too. You can see ether looks like this. It's got an O kind of tucked in the middle of a chain, and the chain has 2 different sides. So one side might have 3 carbons, one side might have 4 carbons, and then in the middle is an ether. And when you name ethers, you can see it's got its own separate kind of class of naming right here. You name each chain from left to right, and then you add a YL suffix for the branches, and then you just use the word ether. So I'm going to show you how to do that. There's no ether here because the word that you call it is an ether, and it will make sense in 1 minute when I show you how to do it. So we're using this one right there. Okay, so let's draw an ether. I'll kind of keep these a little bit simple. Let's go with 3 carbons, an oxygen, and 2 carbons. We're going to add our H's in the middle. Sometimes you'll see the unshared pairs there. You don't have to have them, but sometimes you'll see them. And we're going to slap on all these H's for this ether. Again, identified as an ether because you've got different carbons on each side and you have the O in the middle. So there's my ether. And you name it left to right and you add the YL suffix. So you name each group. So we're going to name this group, add a YL, name this group, add a YL, and then use the word ether. So on the left-hand side, you've got 3 carbons in a row. So that's going to be propyl for 3, and then YL suffix. And then on the right side, you've got 2 carbons, so that's ethyl, and then the word ether tells you that there's an oxygen in between them, so we call it propyl ethyl ether. If they're the same on both sides, like let's say it was this, or 1, 2, and an oxygen, 1, 2, same thing. If it was the same on both sides, then you would say it was di. So you would say, oh, this is diethyl ether for this one that I just drew, diethyl. That's not how you spell things. YL. Oh, yeah, it is. Ether. Okay? So if there's 2 of them that are the same, then you would use the di prefix. Oh, I should mention, too, that a lot of these have a bunch of other, like, more common names, too. We're only learning what we call the official International Union of Pure and Applied Chemistry name, the nerd name, okay? But there's a lot of these things actually are referred to like other things with other more common names. Okay, so let's keep going on some of these. The next one below ether is aldehydes. You can see aldehydes have a separate naming thing as well. Oh yeah, I wanted to erase the ketone, sorry. There's 2 ketones on here and this one's not right. And I have it right on yours, but I don't have it right on this one. So aldehydes. You can see aldehydes are at the end of a chain. So like there's a bunch of carbons over this way maybe. That's what that means. And then there's and at the end of the chain you have this functional group with a carbon double bonded to an O and an H there. So for aldehydes, you can see it's right here. You drop the E from the ane ending and you add the appropriate suffix. And there's no need to indicate where this is because aldehydes are always terminal. They're always at the end of the chain. So if I drew an aldehyde that was 1, 2, let's say 3 carbons, and at the end I've got this, and I've got the OH group, or sorry, no H, just an H. No O, just an H. Okay. If I'm doing that, then this is considered a 3-chain aldehyde. So you can see I've got 1, 2, 3 carbon aldehyde, I should say. Okay. So I actually accidentally drew the same one that's up there, but whatever. So 3 carbons there as part of the chain, and we call this pro, as in propane. Drop the drop the E ending on propane and add Al. So it's propanol. And again, the aldehyde, oopsies, the naming rules are right there. The explanation is right here. You drop the ANE ending and add the appropriate suffix. And again, you don't need to say where because aldehydes are always at the end of the chain. All right, a group that looks like an aldehyde but is not is called a ketone. Ketones are like aldehydes in that they have a carbon double bonded to an O, but they're in the middle of a chain, okay? So these you will need to say, and that's why the correct spot for ketones is right up here, okay? You do basically the same things, but you do have to indicate where it is. Why can't I do anything right? Okay, the indicate where is the important part. So if we drew a ketone that was like, let's see, 1, 2, oh no, 1, 2, 3, 4, 5, 6, we'll say, carbons, and then right here it was carbon double bonded to an O. That's an example of a ketone. Same thing as saying 1, 2, 3, 4, 5, 6, and having a double bond here to that carbon. You can draw it up or down. Of course, all of these will be hydrogens, but let's save ourselves some time and not write them. That's the same exact thing, okay? So when you name it, again, back in the highlighted section up here on the right, for ketones, we're going to drop the E from the ANE ending and add the appropriate suffix. For a ketone, that suffix is ONE, and then we're going to say where it is. So we're going to call this, for 6, we're going to call it hexane. Drop the E, so hexane, and then add the ONE, so hexanone, and then you're going to say where it is. So this is on the 3rd carbon, 1, 2, 3, 3rd carbon, so we call it 3-hexanone. Again, it can point up or it can point down, doesn't matter, it means the same thing, but that's where we get the name for hexanone for that aldehyde. Okay, we're still doing so great. Let's move on to, we have 2 more left, and then we've got organic acids being next, so let's erase some of these things because this is getting kind of sloppy. And do the acid, organic acid. Oh, no, I don't want to erase that. Next. So organic acid is also like a aldehyde in that they're always at the end of a chain. So instead of having the H like an aldehyde has an OH when you identify it. Okay. So and you're just going to add, when you're doing these, add the appropriate suffix, which you can see is organic acid. Oh my gosh, oh right there, anoic acid. And so you use the word acid, just like you use the word acid when we're talking about acids in inorganic chemistry. So if I had something that was like 1, 2, and then it was double bonded to an O with an OH at the end, and that would be the same as saying 1, 2, double bonded to an O with an OH at the end, means the same exact thing. And right here you've got this carbon. This is going to be, say, oh no. Oh my gosh, why? Here we go. Eth for 2 carbons, ane because it's single bonds, drop the E, add ethano, oh man, OIC, ethanoic, and then say the word acid. Okay. Oh, I forgot my H3. And like I was saying previously, I mean, yes, this is the official book name for this acid, but ethanoic acid, guess what, is the same as this HCH. Oh my gosh. C2H3O2. Same thing as acetic acid, which we've been calling it for the last month. And it's just an example of how there's a lot of common names for some of these things that are more common that are not the same as the official organic name. Okay, and the last one is an ester. And esters are, I don't know, maybe the most complicated one. The esters are here. Carbon double bonded to an O with an O next to it as part of a chain. And you name these ones backwards. So that's the trick with esters, is that you name them from right to left. So as you can see here for esters, name each chain from right to left, add the O8 ending, use the YL suffix. Okay, so for esters, it's kind of backwards, but that's just the way, the convention, that's the way that they're named. So if I drew one, I'm going to draw it right here. 2, 3, 4. And I'm going to put my hydrogens into it. Sometimes all these dots there, I don't know why, I just got crazy, I did it. Add my hydrogens. All right, so this one's the most random in terms of names. You do use this, let's get rid of this, O8 ending. It's a little random for esters, O8 ending. And kind of like for when you do ethers, you're going to use the YL as part of like what's on each side of the chain, except you start from the right first. So we say that there's one carbon there, so we say methyl. And then this all together, what is it? 1, 2, 3, 4. There are 4 carbons there, and so we call that methyl butanoate. Methyl butanoate. So the first part gets a YL ending. The second part, you drop the E and add the O8 ending again, because there's 4 carbons on the left-hand side of that. That is what you go with. And the oxygen is what separates them out. And you can see that is the same as saying here. The oxygen separates them. And in this example, you've got the methyl group 1, 2, 3. Oopsies. Methyl group. And then the carbons for the prop is 3 carbons, 1, 2, 3 carbons on the left-hand side. All right, so you do count that carbon that's directly below the oxygen. So there's an example of how to name and write some of the structural formulas for some things that we call substituted hydrocarbons, which include functional groups that are different than the original simple hydrocarbons. This has been super fun. Everyone take care. Okay, bye.